My name is David Joyner, and I work for Udacity.
In fall 2014, Udacity changed its model. Instead of just providing individual MOOCs made of multiple videos and maybe some exercises, Udacity started to build what it called nanodegrees. Nanodegrees were a series of project-based curriculums where each project was supported by some video material, some MOOC, but the focus of the nanodegree was really on these projects. Now, MOOCs were designed so that hundreds of thousands of students could take a course without having to hire more staff. And as such, they rely on certain kinds of assessments, certain kinds of material that don't require more people to be hired in order to handle a greater number of students. Much of this material is autogradable. It might be autogradable because it's multiple choice or short fill in the blank. It could also be autogradable because it's graded based on a simulation or graded based on a set of criteria. But the important thing is that it's graded not by a person but by a computer. Oftentimes this is mathematical. Mathematical answers can often be graded by computers in ways that essays can't. Code segments are similar. Code segments often have predictable output, or you know what they're supposed to produce, so it can automatically evaluate those as well. Or for those more open-ended things, they rely on peer grading. Nanodegrees, on the other hand, are more project-based. They're usually based around some open-ended projects where students can actually define what they want to do or have some element of creativity in it. They often involve reports on how certain analytical methods worked or how certain processes worked. Typically, they involve delivering applications, and the student actually defines for themselves what kind of application they want to design. And oftentimes, they involve expert feedback. So instead of peer review or automatic review, experts actually review these projects and give their own feedback, as well as passing the student or asking them to try again or revise their work. So whereas MOOCs are based around assessments that can be uploaded to the cloud and evaluated automatically, nanodegrees are based around assessments that have to be provided to a panel of experts and evaluated manually. So what does this process look like? Well, a student in a nanodegree program delivers some application, delivers some report, delivers some project, and that's then sent to some expert reviewer who will look over it, give some feedback, as well as decide if that student is ready to move forward in the nanodegree program. They generate a grade report as well as some feedback that is sent back to the students. The challenge here is scale. In Udacity's nanodegree programs, there are hundreds of projects generated every single day, and we'd like to get those back to students in a pretty quick time period. These are in advanced subjects like iOS development or data science. These aren't things that thousands and thousands of people on the street can just evaluate in their spare time. And if that sounds like a challenge on its own, consider also that students can submit their projects an unlimited number of times. Graders can take up to an hour to evaluate each project. Graders are expected to provide written feedback on those projects. And these students are only paying $200 a month. This presents a massive scaling problem because the tuition is so low and the number of projects and the complexity of the projects is so high.
In traditional classrooms, it's not uncommon for students to wait a few days or a week for feedback, and that's with a much smaller class size. How do you get expert feedback to students quickly with over 300 submissions per day?
Enter the project reviewers. The project reviewers for these nanodegree projects are experienced pros from industry. They're exemplary nanodegree graduates, or they're qualified Udacity course managers, people who work for Udacity and help to develop the curriculum that's in these nanodegree programs. Now, how does one become a project reviewer? Well, to start with, if the student hasn't already completed the project, they do it themselves, and that's sent on to an existing project reviewer. That project reviewer determines whether or not that student has passed the project, and if they have, they're qualified to then apply to become a project reviewer. Once they apply, they take a Udacity project review course that tells them the kinds of feedback we expect them to give, the kinds of criteria we want them to look for. Depending on the project that they want to review, they might also take a project-specific review course that gives them more content knowledge on the specific project that they're trying to evaluate or give feedback on. After that, the applicant is given a project that we've already evaluated to evaluate, but the evaluation we gave is hidden from them. They then evaluate this project on their own, and that evaluation is sent on to one of the existing project reviewers. That reviewer will then look at the review that the applicant generated and compare it to the review that we've generated in the past, the one that we accept, the one that's kind of the correct review. If it's not a match, if it's not pretty similar, if the feedback isn't good enough, if the assessment doesn't match the one that the existing project reviewer gave that project, then the applicant is asked to try again, and they're given some feedback on what was missing or what was lacking or what was different. But if the review matches, and if in fact a few reviews match, they are asked to do multiple projects this way, then the applicant is approved to become a project reviewer. Once they're approved, they're added to the pool of potential reviewers, and they may be able to see the list of projects that students have submitted. When they want to do a project review, they select a project, look at it, review the code, run it, give whatever kind of analysis that kind of project demands, and provide a review to the students. Then they're paid per review that they give. So every time they review a project, they're paid individually for that project. What they're paid differs based on the scope of the project. Now, when the reviewer provides an evaluation, they provide two different things. They provide a yes/no on various different criteria that the rubric expected students to meet on the project to assess whether or not they've met the learning goals of the project. And they also provide some written feedback to the student on how they can improve or what they should do differently next time. This review is then sent on to the student so they can improve on that given project or have some insight into what they should do differently on future projects. The cycle doesn't end there though. We're strong believers in feedback cycles on both ends of the process, and so the student can then provide a review back to the reviewer. They mark whether or not the review was helpful or unhelpful, and they can also provide written feedback to their reviewer about what they would like to see more of or what kind of feedback they really needed.
So how do we know if this works? Well, there are 3 metrics that we use.
One of the metrics we can use is the number of projects evaluated. I mentioned at the beginning that the real challenge with this kind of system is scale. How do you handle lots of reviews this way? Well, after over a year, this system is handling scale very nicely. Right now, this process is handling 450 project submissions per day. You'll notice that's different than the number I mentioned in the paper and in the title of this presentation. This was written in October when the average was 300 projects per day. Now, only 6 months later, it's up to 450 projects per day that are being handled by this system. But that's not that great an achievement if students are still having to wait a long time for feedback, if we have a long backlog. So what's the turnaround time like? Well, the turnaround time is 87 minutes right now. 6 months ago, it was 138 minutes, around 2.5 hours, which is still great. 6 months ago, it was 138 minutes, or about 2.5 hours, which is still a pretty rapid turnaround time, but it's gone down enormously since then, and right now it's sitting at 87 minutes for projects submitted in the past week. Now, these two metrics together could be very easy to achieve if you don't care about student satisfaction. But we do care about student satisfaction, and we see students highly satisfied with the reviews they're receiving, giving an average of 4.8 out of 5 on those reviews that they provide back to the project reviewers.
So this workflow is successfully evaluating over 400 projects every day with a rapid turnaround time and high student satisfaction within a $200 per month program. It's safe to say that it's met its original goals of scaling this kind of assessment. But as someone who's really personally passionate about education, what I care about most is how it actually improves the learning process.
That very short turnaround time means that students are getting very rapid feedback. They're able to submit a project and go have dinner, maybe watch a TV show, come back, and already have feedback on what they did. Now, rapid feedback cycles are always a good idea, but their usefulness is limited if you don't get to try again on what you just got feedback on. But when you add to that the ability to iterate multiple times, iterate an unlimited number of times over a project submission, what you get is a fantastic example of formative assessment in action. That's a type of learning that's incredibly exciting to me.
What's most remarkable about this is that it isn't just figuring out how to do learning at scale. It's figuring out how to use scale to improve learning. Evaluating 400 projects per day isn't a challenge. It's an opportunity to drastically improve the rate and quality of the feedback cycle in education. Thanks for watching.